Problem 4 on page 22 is asking us to graph the following equations. And so the first thing I want to do is actually get these equations in the form y equals mx plus b, because this is going to make them a lot easier to graph. And so in each of these cases, what I'm going to do is solve for y. So starting with equation 1, I have 2x minus y equals 1, and I'm going to subtract 2x on both sides of the equation, which gives me negative y equals negative 2x plus 1. And I want a positive y on the left side of the equation so that it satisfies this general form. So I'm going to divide both sides of my equation by negative 1. This gives me y equals positive 2x minus 1. I'm going to move on to part 2 before I start graphing these. So in equation 2, I have x plus y equals 2. And so I'm going to subtract x on both sides to get y by itself. This gives me y equals negative x plus 2 for equation 2. And in equation 3, what I have is 4x plus 3y minus 6 equals 0. And in this case, I'm going to subtract 4x on both sides. And I'm also going to add 6 on both sides, just to do this all in one step. So this gives me 3y on the left side equals negative 4x plus 6. And now I'm going to divide both sides of my equation by 3 to get y on its own. This gives me y equals negative 4 over 3 times x plus 6 divided by 3 is 2. So I have negative 4 over 3 times x plus 2. And so you can see that now we have all these equations in the form y equals something times x plus or minus something. So this is going to make it easier to graph. This is because our m is our slope and b is our y-intercept. So we can look at each of these equations and figure out how they'll look on the graph. So for equation 1, we have our b is negative 1. So this means that this graph crosses the y-axis at negative 1. So I'm going to put a point here at negative 1. And to plot the other points on this graph, the way I think it's easiest to do is to look at our slope, which in this case is 2 here, and realize that m, our slope, is equal to the rise over the run between 2 points. So a slope of 2 means we rise 2 units for every 1 unit we run horizontally. So this means that I can plot points just by going up 2 units and across by 1 unit, which gives me a point here. And I'm just going to plot one more point on this line by going the other way, so going down 2 units and across 1. This gives me this point here at x equals negative 1, y equals negative 3. So you can see that we have, when we draw this line and connect all these points, we have a positive slope because for every 1 unit we go across, we're rising 2 units. So this is the graph for equation 1. So I'm just going to write a 1 here. So let's do number 2 now. In number 2, we have a y-intercept of positive 2. So this means that we have a point here, and we have a slope of -1 because we have a coefficient of -1 on our x. So this means that we are decreasing y by 1 unit for every 1 unit we're running across horizontally. So if we do this here, we're going down 1 unit and across 1 unit. So we have actually this point is also on our second line. And I'm just going to go the other way too. So cross 1 unit, up 1 unit here. And if we connect these points, you can see that we are going down by 1 unit for every unit we're going across, so we have a slope of -1 for this line. So that's equation 2. And for equation 3, we actually have the same y-intercept plus 2, so this point is also a point on equation 3. And in this case, our rise over run is -4/3. So we're going down 4 units for every 3 units we go across. So I'm going to go down 1, 2, 3, 4, and across 1, 2, 3 to give me this point here. And going backwards, I'm going 1, 2, 3, 4, 1, 2, 3. And this is another point on this line. So it's a little bit confusing maybe that we're going up and across in this case, but you can see that it's just because we were going backwards on the line. So when we look at all these lines all these points together, you can see that as you're going across 3 for x, you're going down 4 in each case. So that's why we have a -4/3 for our slope. And so this is our equation 3. And so we've completed the problem. We've graphed all the following equations.